National Electrical Code Section 300.4F addresses the requirements for insulated fittings where raceways contain conductors of number 4 or larger. This section is crucial for ensuring the safety and longevity of electrical installations. The primary purpose of requiring insulated fittings is to protect conductors from abrasion and damage as they enter or exit a raceway. When conductors are pulled through raceways, especially larger conductors, the edges of the raceway can act like a knife, potentially damaging the insulation of the wire. This damage can lead to short circuits, ground faults, and alternately, electrical fires. Insulated fittings provide a smooth, rounded surface that prevents this abrasion, safeguarding the integrity of the conductor's insulation. The scope of 300.4F applies specifically to conductors of size number 4 American wire gauge and larger. This is because smaller conductors are generally more flexible and less susceptible to damage from raceway edges. However, when dealing with larger conductors, the forces involved in pulling them and their inherent stiffness increase the risk of insulation damage. The requirements of 300.4F dictate that where number 4 or larger insulated conductors are installed in a raceway, a fitting providing a smooth, rounded insulating surface, such as an insulated bushing, must be used at the end of the raceway. This fitting should be properly sized for the conductors being used and securely attached to the raceway. The fitting must be suitable for the environment in which it is installed. For example, if the raceway is exposed to moisture or corrosive substances, the fitting should be made of a material that is resistant to these elements. The insulated fitting acts as a barrier between the conductor and the potentially sharp edge of the raceway. By providing a smooth, rounded surface, it allows the conductor to bend and flex without coming into direct contact with the raceway edge. This reduces the risk of nicks, cuts, or abrasions to the insulation. There are several types of insulated fittings available. Firstly, insulated bushings are among the most common. These are typically made of plastic or metal with a plastic liner. They are designed to fit snugly onto the end of the raceway, providing a smooth, rounded surface for the conductors to pass through. Secondly, insulated connectors, which are similar to insulated bushings, but they also provide a means of connecting the raceway to an enclosure or other equipment. Thirdly, grounding bushings. These are used when grounding is required. They provide an insulated surface for the conductors as well as a means of connecting a grounding conductor. The installation of insulated fittings should always be performed according to the manufacturer's instructions and in accordance with the National Electrical Code. Proper installation is essential to ensure that the fitting functions as intended and provides adequate protection for the conductors. Before installing an insulated fitting, it is important to inspect the raceway end for any sharp edges or burrs. These should be removed to prevent damage to the fitting or the conductors. The fitting should be securely attached to the raceway using appropriate hardware, such as lock nuts or screws. The conductors should be carefully pulled through the fitting, ensuring that they do not come into contact with any sharp edges. It is important to avoid over-tightening the fitting, as this can damage the insulation of the conductors. Section 300.4F helps to prevent electrical hazards and ensure the long-term reliability of electrical systems. By protecting conductors from abrasion and damage, insulated fittings reduce the risk of short circuits, ground faults, and electrical fires. The use of insulated fittings also helps to extend the lifespan of conductors by preventing insulation degradation. This can save money in the long run by reducing the need for costly repairs or replacements. The requirement for insulated fittings applies to various types of raceways, including rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and flexible metal conduit. The specific type of fitting required may vary depending on the type of raceway being used. In addition to protecting conductors from abrasion, insulated fittings can also help to reduce the risk of corrosion. When dissimilar metals are used in electrical systems, such as copper conductors and steel raceways, galvanic corrosion can occur. This is an electrochemical process that can cause the metal to degrade over time. Insulated fittings can help to prevent galvanic corrosion by providing a barrier between the dissimilar metals. The National Electrical Code is a comprehensive set of standards that provides guidance on the safe installation of electrical systems. It is updated every 3 years to reflect the latest advances in technology and best practices. It is important for electricians and other electrical professionals to stay up to date on the latest edition of the National Electrical Code and to follow its requirements carefully. The use of insulated fittings is just one example of how the National Electrical Code helps to ensure the safety and reliability of electrical systems. By following the requirements of the National Electrical Code, electrical professionals can help to prevent electrical hazards and protect people and property from harm. It is essential to use the right size insulated fitting. The fitting should be large enough to accommodate the conductors being used, but not so large that it allows the conductors to move around excessively. The fitting should also be compatible with the type of raceway being used. Some fittings are designed for use with specific types of raceways, while others are more versatile. When selecting an insulated fitting, it is important to consider the environmental conditions in which it will be installed. If the raceway is exposed to moisture or corrosive substances, the fitting should be made of a material that is resistant to these elements. In some cases, it may be necessary to use a fitting that is specifically designed for wet locations or corrosive environments. There are several different methods for installing insulated fittings. The specific method used will depend on the type of fitting and the type of raceway. In general, the fitting should be securely attached to the raceway using appropriate hardware, such as lock nuts or screws. The conductors should be carefully pulled through the fitting, ensuring that they do not come into contact with any sharp edges. Insulated fittings are an essential component of safe and reliable electrical installations. By protecting conductors from abrasion, corrosion, and other types of damage, insulated fittings help to prevent electrical hazards and extend the lifespan of electrical systems. The National Electrical Code requires the use of insulated fittings in certain situations, and it is important for electrical professionals to understand these requirements and to follow them carefully. The cost of insulated fittings is relatively low compared to the potential cost of electrical accidents or system failures. Investing in high-quality insulated fittings is a smart way to protect people and property from harm and to ensure the long-term reliability of electrical systems. In addition to the requirements of the National Electrical Code, some local jurisdictions may have additional requirements for insulated fittings. It is important to check with the local authorities to ensure that all applicable requirements are being met. The inspection of electrical installations is an important part of ensuring safety and compliance with the National Electrical Code. Electrical inspectors will typically check to ensure that insulated fittings are being used where required and that they are properly installed. If an electrical inspector finds that insulated fittings are not being used or are not properly installed, they may issue a violation notice. This notice will typically require the electrical contractor to correct the problem within a specified time frame. Failure to correct the problem can result in fines or other penalties. Proper maintenance of electrical systems is essential for ensuring their continued safety and reliability. This includes regularly inspecting insulated fittings for signs of damage or wear. If an insulated fitting is found to be damaged, it should be replaced immediately. Electrical safety is a shared responsibility. Electricians, electrical contractors, building owners, and homeowners all have a role to play in ensuring that electrical systems are safe and reliable. By following the requirements of the National Electrical Code and by taking other appropriate safety precautions, we can all help to prevent electrical hazards and protect people and property from harm. When working with electrical systems, it is important to always follow safe work practices. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses. It also includes energizing electrical circuits before working on them. If you are not qualified to work on electrical systems, you should hire a qualified electrician to do the work for you. Working with electricity can be dangerous, and it is important to take all necessary precautions to protect yourself from harm. Insulated fittings play a critical role in ensuring the safety and reliability of electrical systems. By understanding the requirements of the National Electrical Code and by following safe work practices, We can all help to prevent electrical hazards and protect people and property from harm. Remember to always consult the latest edition of the National Electrical Code and any applicable local codes for specific requirements.